Okay, 8th grade. We've been talking about motion, speed, acceleration these past couple of weeks, so I'm going to do a quick review that might help you with your homework you have tonight, as well as on your test on Friday. So really quickly, we're going to go over some definitions and solve some problems. Okay, first of all, motion. If something's moving or in motion, what does that mean? It means when an object changes a place or position. Okay, so to properly describe motion, you need to know the following. What's the start and the end position? Movement relative to what? Now this, movement relative to what, means to a reference point. Now we had that term in our reading. Reference point is, for instance, a object that's not in motion can be used as reference points. So he moved 2 feet from the stop sign. Okay, so that's what a reference point is. Okay, how far did it go? Well, that's when we get into units such as kilometers, meters, centimeters, and then in what direction did it go? Northeast, southwest, etc. Okay, so speed. Speed is actually the distance an object travels in a certain time. Speed is the distance an object travels in a certain time. For instance, if I drive from Oklahoma City to Tulsa, that's a distance of 100 miles, and I do it in 2 hours. To calculate the speed I had between them, we use the formula, the speed as s is equal to the distance divided by the time. So the distance was 100 miles. Okay. The time was 2 hours. Okay. So it would be 50 if you did the math, put the distance in the calculator. So if you put 100 divided by 2 hours, you get 50 miles per hour. So here's another example. Suppose you ran 2 kilometers in 10 minutes. What is your speed? Well, the distance was 2 kilometers. The time it took was 10 minutes. So 2 divided by 10 is 0.2 kilometers per minute. Be sure and include your units in this, or this number means nothing. As every calculation we've done in science, you've got to have your units or it doesn't make any sense. No naked numbers, as we always say. So the distance divided by the time, and be sure and include your proper units there. Okay, so with speed, there's 3 kinds of speed. There's constant speed. That's when you're traveling at the same rate. Okay, so if you set your cruise control for 55 miles per hour, then that is what your speed's going to be until you brake or increase your speed. So that's constant speed. The average speed is what that formula calculates. It's taking the total distance you traveled and divide it by the time. And for instance, on that last problem where we talked about driving to Tulsa, okay, for that whole 100 miles, you are not traveling at a constant speed. You might be traveling, you know, if you're passing someone, you might be traveling a little faster, or if you're slowing down, you might be traveling a little slower. So the 50 miles per hour or whatever is an average of the time. You might be, like I said, you might be traveling 60 some of the time and 40 some of the time, but your average speed was 50 miles per hour. Now, the third type of speed is called instantaneous speed. That is your speed at an exact point in time. And this would be, for instance, the speed that a radar detector would get you at. The policeman might say, well, you were going 75 when he put his radar on you. Well, that's the speed you were traveling at that point in time. You might say, oh no, officer, I was actually only going 55 miles per hour as your average speed it would have taken you to go from one place to another. But an exact point in time is your instantaneous speed. Okay, so if we do some graphs, we look at this graph here, and what it is showing, the independent variable on the bottom is the time. The distance is over here as the dependent variable. Okay, and notice how this nice graph has the units over here. The units is in meter, the time is in seconds, and this actual boat was plotted at 2 seconds. It was at 20 meters. At 3 seconds, it was at 50 meters, etc. So the average speed, to calculate it, is, well, you go and find out what the total distance he went from. Well, he went from 0 to 125 meters. Okay, well, how long did that take? Well, he was at 0 at 1 second, and at 9 seconds, right here, he was at 125 meters. So his total distance was 125 meters. The total time, well, from 1 second to 9 seconds is 8 seconds. You do the math, you take 125, divide it by 8, and you get 15.6. What are your units? Meters per second. So his average speed is 15.6 meters per second. Did he travel at that speed the whole entire 125 meters? No, he did not. But his average speed for that distance was 15.6. Okay, his instantaneous speed, well, first of all, you have to know at what point in time you want that speed. Okay, so to calculate instantaneous speed, you have the distance and that exact point in time. So what is instantaneous speed of the boat at 7 seconds? Well, at 7 seconds, he was at 85 meters. So 85 meters divided by 7 is 12.1 meters per second at that point. Okay, so here's another more extended graph here. In what period is the bass boat speeding up? Well, his distance versus his time is going up right here. So between 1 second and 4 seconds, he is actually speeding up. Now, what period of time is he slowing down? Well, when the graph goes this way, where his distance versus time is actually showing a negative slope, is from 6 seconds to 9 seconds. Where is it not changing? Well, when you got a flat line right here, his speed is not changing at all on that part of the graph. So between 4 seconds and 6 seconds, his speed's not changing at all. Okay, so if you were to graph speed, you use a line graph, and it depicts the distance and the time. The time is the independent variable, and the distance is the dependent variable, so we put it on the y again. Okay, now velocity, again, we talked about in class, is the speed of an object, but the direction is included. It is calculated the same as speed, so use the same formula, but you must include a direction in your answer when I'm asking for velocity. So the bass boat was moving 12 miles per hour north. It says towards the north here, but north is good. Okay, now acceleration. A lot of you have some trouble with this. It's the change of your velocity. It's the rate of change. How fast are you speeding up? If that new car can go from 0 to 60 in 5.3 seconds, that's its acceleration. Now, acceleration can also be negative, in other words, slowing down, and we call that deceleration. Okay, and it has a negative value, so it usually has a negative in front of the answer. So, okay, so another formula. Your acceleration can be calculated by taking the final velocity, the ending velocity or speed that that object is traveling, subtract the initial velocity from it, and divide that whole thing by the amount of time that it takes for that change in speed. Now, units. Usually, it's in units like meters per second, or meters per second squared. Now, what that means is, say this was a, go back. Say this was 5. Okay, so say this man on the wheel there is changing his speed at a rate of 5 meters per second. What that means is every second he is changing his speed, increasing his speed by 5 meters per second. Okay, so if this is at, he started at 0, well, at 1 second he'd be at, his speed would be 5 meters per second. At 2 seconds, his speed would be 10 meters per second. At 3 seconds, his speed would be 15 meters per second. Okay, so that's what acceleration is. It's your change in speed. Okay, so let's do a practice acceleration math problem. All right, you got a jet. It starts at rest at the end of a runway. Okay, so again, I challenge you guys all the time, but write out what you know. Okay, just starts at rest at the end of a runway. So if he's starting, that's his initial speed, or his V1. Okay, if he's at rest, well, that simply means that his speed is 0 meters per second. Okay, he reaches a speed of 80 meters per second in 20 seconds. Okay, so his final velocity, or his V2, is equal to 80 meters per second. Okay, and it took him, or the jet, I should say, 20 seconds to go from 0 to 80. It took him 20 seconds. So that's the time, which is T. So T equals 20 seconds. Okay, so if we plug that into our formula, 80 minus 0 over 20. Okay, well, if we do the math, which hopefully you can do that in your head, it equals 4. Now the units are meters per second every second. So that means that jet is increasing speed by 4 meters per second every second. Okay, so there's the answer. Okay, here's another one. A skateboarder is moving in a straight line at a speed of 3 meters per second and comes to a stop in 2 seconds. Now, what's his acceleration? Okay, he's decreasing his speed here, so that's called deceleration. So if we put that into the formula, his ending speed, or his V2, is 0. His starting speed was 3 meters per second, and it took him 2 meters per second to stop. So if we do the math there, minus 3 divided by 2 is equal to a minus 1.5. And that's called deceleration. Okay, so with that, finish working your problems. They get a little bit more difficult as you go because they might give you the acceleration, and they might give you the initial speed and the time, and you have to find out the final speed. But that's simply doing algebra, turning the numbers around to solve for a different variable. And we'll go over the homework problems tomorrow, and we can ask questions.